I welcome you all for the lecture series in Basic Civil and Mechanical Engineering. So, introduction to friction welding is today's topic. Friction welding is a solid state joining process where heat is generated by the relative motion between two surfaces, resulting in high strength, defect free weld. The versatile technique is used across industries from aerospace to automotive to create robust and uniform joints. So what are the principles of friction welding? Heating, forging, and consolidation. These three things happen when two metals are allowed to rub together to create friction. So heating, the frictional heat is generated between workpieces, raises the temperature, softening the metal and preparation them for welding. Once heated, the parts are pressed together under high force, causing the softened materials to forge and flow, creating a strong metallurgical bond. So in the consolidation stage involves the consolidation of the weld where material cools and solidifies, forming a seamless joint. So we have what are the types of friction stir welding? We have linear friction stir welding, we have rotary friction stir welding, and friction stir welding and friction surfacing. Linear friction stir welding oscillates the part linearly to generate and create weld. So that means the axes are parallel between the rubbing surfaces. And rotary friction stir welding rotates one part against the stationary other part to produce the weld. So again, the axes are in line, collinear, so that one part is kept stationary in a lathe and the other part is made to rotate against to get it rubbed with the other part to get friction and softening of the metal. And one of the most interesting solid state welding is friction stir welding, where it uses a spinning tool to generate frictional heat and force the materials together. So the next type of welding is friction surfacing. Despite deposits a very wear resistant coating on a base material through frictional heating. So this is surfacing is nothing but improving the properties of surface only, not the subsurface, so that the material used or the cost involved to produce any material gets lower. It's like a coating. So what are the applications of friction stir welding? We have enormous applications. It is majorly for automotive, aerospace, and energy. So it is used to join drive shafts, suspension components, and engine parts. In aerospace, it is employed in the fabrication of jet engine components and airframe structures. In the energy, it is applied in the production of turbine blades, nozzles, and other power plant parts. So what are the advantages of friction stir welding? It is a high welding which gives high strength. The weld zone exhibits excellent mechanical properties, often exceeding the strength of the base metal. Minimal distortion. The local heating and forging process minimize warping and distortion of the workpiece. The very interesting part of this kind of welding is there is no filler material. It is an autogenous process, eliminating the need for filler materials or fluxes. The number 4 advantage is environmental friendly. The process is clean, energy efficient, and does not produce or any harmful emissions or byproducts. So what are all the process parameters that influence friction stir welding? So we have 3. One is rotational speed. Higher speeds generate more heat and affect weld quality. Forge force. Optimal force ensures proper material flow and joint formation. And offset allowance, the amount of axial shortening during welding critical for joint strength. So this is how the process parameters controls friction stir welding quality. So what are the quality control in friction stir welding? One is after welding, we have to go through all these 4 tests to ensure high quality weld is being produced. One is visual inspection, checking for the surface defects, flash formation and joint appearance. Non-destructive testing, employing techniques like ultrasound and X-ray to detect internal flaws. Mechanical testing, evaluating weld strength, hardness, and other mechanical properties. So in the microstructure, we have to analyze the composition of the weld zone. So what are the future trends in welding? Automation and robotics. So the friction stir welding can be made, making automation and a hybrid process combining friction stir welding with other techniques such as laser or induction heating for enhanced vessel welding. Advancements in materials, expanding the range of materials that can be effectively joined through friction stir welding, including metal, plastics, and composites. So now the latest trend is to integrate Industry 4.0, integrating friction stir welding into a broader framework of smart manufacturing, delivering data analytics and Internet of Things. So with this, we will conclude this lecture series. Thank you.